and I'm here to talk to you about a facet of reproducibility that I think is less commonly spoken about, and that is reproducibility and dataset construction. Oh, okay. So I'm going to work through a case study of my work with Rohan Alexander, digitizing the Australian Hansard, to give you some ideas on how you might implement reproducible practices into constructing a data set using code. Before I start, I just want to thank Rohan for letting me do this work with him and also helping me sort of articulate my thoughts in the best way to give this talk to you all today. So I want to start out by talking about reproducibility in research sort of broadly. So I think we all agree that data sets and code are super important core components of social science research. So being able to clean, process, model, and analyze data using code are fundamental prerequisites of computational social science. While not as widely adapted as we would like, there are some really well-established approaches to reproducible workflows and tools to implement that in this type of research. So GitHub, our projects, and more broadly, just like emphasis on better documentation. And when we think about reproducibility in this context, at least when I think about it, I think about sort of being able to replicate or use someone's code or the logic behind their code to obtain that single finding or set of findings based on their set method. But what I want to talk about today is looking at the reproducibility of code that's actually used to construct a data set. So thinking beyond code used to get like a single finding and thinking more broadly in the framework of data sets. So the thing about dataset construction using code is that I think it's far less cut and dry than the sort of methods for a typical social science replication project. I think the methods are a lot more involved, and I think it's difficult to sort of articulate them and share them in their entirety. So the issue is that it's really important for the people who are using the data set that we construct to understand the way that it's clean and the assumptions that underpin the way it was created. So this is super important. However, there isn't actually a lot of focus on this in the reproducibility framework, I think, for three main reasons. So one, it's only relatively recently that data sets have actually become too big to inspect manually. Second, it's only relatively recently that data sets have actually been primarily constructed using code. So when I think about like a typical data set, you think about something like survey data or census data or patient level data that's been manually collected. So sort of the construction using code is sort of new. And finally, often we just can't share data sets because it's subject to confidentiality or any other reasons. So in this talk, I'm going to walk you through how you can implement an element of reproducibility into dataset construction with code. So as I mentioned, I'm going to use the case study of my work with Rohan on digitizing the Australian parliamentary debates, also known as the Hansard. For those of you who don't know, Hansard is the traditional name for the official written record of parliamentary debates in Australia. The concept of Hansard originated in the British Parliament and remains tradition in a number of Commonwealth countries, including Canada. The Hansard records capture all parliamentary proceedings, and they are essentially, but not entirely verbatim. So they're a super valuable, rich resource that we want to use for research. About a week or so after each sitting day, two forms of Hansard are made available on the Australian Parliament website. So the first is the static PDF. This is designed for human readability, and it's like the official release. And the second form is extensible markup language, or XML. And this is designed for machine legibility. And we can obtain the XML from the PDFs using optical character recognition technology, though the conversions are often flawed, especially for the early decades of Hansard. And the reason I'm showing you this is because I want to emphasize that the way Hansard exists in these two forms, it's not actually accessible for the purpose of large-scale text analysis. So there's no like comprehensive data set that will enable a researcher to sort of analyze all of these records at once. And so we make use of the fact that we have these XML records, which are machine legible and can be manipulated at scale using code. And this leads me to sort of the goal of our project, which is to create that publicly available database containing one CSV file for each sitting day of the Australian Parliament from 1901 to the present day using those XML formatted transcripts where we have them available. We want each CSV in our database to contain everything recorded in that Hansard record from that day, where all statements are separated onto their own rows, ordered chronologically, and details on who is speaking are correctly filled in. I'll briefly mention that this has been achieved for Canada, so the Linked Parliamentary Data Project has done this if you want to check it out, and we're really following their lead in our work here. So far, we have developed 4 scripts which successfully parse all XML formatted Hansard records from the House of Representatives from 1998 to 2022 and produce tidy CSV files that look like this. So this is just the first 15 rows of about 400 of one of our CSV files. You can see there's a bunch of added variables, so details on who's speaking, the time, what's being said, details on like the gender, a unique identifier, as well as a number of binary flags that we added to allow for easy filtering of statements. So now that you have a sense of what we've done and why we did it, I'm going to walk you through the method, and then I'm going to get into how we actually implemented this element of reproducibility into our dataset construction. So we just started out by working through one XML file to identify the various components of interest within that file and the corresponding structural form. So XML is basically just a series of nested elements, each element serving as a container for some part of the data. So it's really important to understand the structure before going ahead and trying to navigate the document. So once we had a sense of what we were working with, we could then actually write the code to parse everything and then use that, turn it into a script, which combined all the components chronologically and did all the processing that we wanted, like splitting things up and filling things in. To this point, this was all just for one sitting day. So the next step was to generalize that script to parse other sitting days, working back in time and modifying the script as needed. So the final step, which is a step I'm going to get into next, is validating the data using automated testing. So the thing is, before we want to publish this data, we have to check it somehow. And that is a key point of like why we're embarking on this project, is to make it publicly available. And because a lot of, like I mentioned, it's not really cut and dry like the methods. There's a lot of decisions and assumptions that go into data set construction. It's really important to check it and sort of validate to the users how you've done that. So the way that we approach this issue of checking the data, because it's so large, we decided to write a series of tests which can actually be readily reproduced by anyone. And the point is that every single file in our database has to pass these tests, and we can share them so that people who are using our data understand the logic behind those tests. So I'm just going to walk you through the 7 tests that we actually designed to validate our data. Like I said, every single file in our database had to pass these tests. So for the sake of time, I'm just going to talk through the ones that are bolded, but we did write 7 tests. So the first one that's bolded is we want to check that there's an equal number of flagged questions and answers. That's something that we assumed when we were parsing and merging the data. So we had to check that that actually held true. The next one is where the phrase time expired exists in a body of text. Check that it is at the very end. That one I'm going to explain in a little more detail in a minute. And then the last 2 bolded ones, those are motivated by the fact that we added a bunch of identification variables. So everyone speaking, we wanted to add their gender, a unique ID, stuff about their political affiliation. And because we were working with so many files at once and wrote the code to do this at scale, we wanted to check that we weren't like misattributing something to the wrong person. So we made use of the Australian politicians package, where we have the date of birth and where applicable death for every MP, as well as the dates that they are actually members of parliament. So we made use of those to make sure that the presence of each individual actually aligns with their recorded lifetime and membership in parliament. So I'm just going to walk you through the logic behind one of the tests so that you can see sort of how we thought this through and the way that it can be readily reproduced. So the second test I'm going to talk about is the time expired test. So basically, when somebody is speaking and they run out of their allotted time, they're cut off, and then the Hansard editor will transcribe the phrase time expired after their final word. So intuitively, we expect that wherever this phrase exists, it shouldn't be followed by additional text. And if it is, that means that we forgot to separate the next statement onto its own row. So what we did is we looped through every single file in the database and filtered for any rows where that phrase time expired exists, but is also followed by more text, grabbed all of those rows and then appended the file name onto it so we could keep track of these issues. And this is the output of that test. So this is just part of it. There were more errors than this, but we caught a bunch of stage directions and statements that were not correctly separated onto their own rows. And the reason I want to show you this is because these are all things that we wouldn't have actually caught had we not validated our assumption or expectation of the data. So data validation is super important, and this is a good example of why. So to summarize this section, I just, because I know that the ones that I showed you are super context dependent, right? It really depends on the data you're working with and the project. So I just want to give you sort of three rules of thumb to think about on how to make effective data tests that can be readily replicated and shared publicly. So number one, think about common issues that you ran into during parsing. You may think that you caught all the problems because you caught every time your code broke, but it's very possible that you didn't. So make sure that you check those. Number two, the assumptions that actually underlie your approach. So I know I said this a couple times, but like there's a lot of decisions that you make when you're deciding how to parse and process and merge all the data together. It's really important to test those assumptions because otherwise, you know, the people using your data won't know what those assumptions were and whether they're actually true. And finally, think about standard characteristics that you expect to see across all files. So the time expired one that I just showed you is like a prime example of that, just something that we expect given the nature of the data we're working with. So it's important to check on those. So you might be wondering, what about other programming languages? I want to emphasize, like, while this was done in R, super language agnostic, this like really doesn't depend on the language. It's more about the logic. So just to give another example, I'm actually implementing this data validation approach in another setting using Python. So I'm doing some work for the Investigative Journalism Foundation, which is a public interest journalism nonprofit that has 8 databases that they've created basically on Canadian sort of political donations, political lobbying, and charities. And this is based on data that has been scraped and is continually being scraped, as well as historical records. And so obviously this is super important to validate because people are going to be basing stories off of this. And so I'm working on implementing a suite of data tests that the data has to pass to make it onto their database. And so two open source libraries I just want to mention that actually allow you to do this is Great Expectations in Python and Point Blank in R. They are designed for this, and they allow you to implement pre-built data tests into your data stack and provide actually really interesting reports on the metrics associated with each test that can be updated as new data is being ingested into the database. So to finish off, I'll just give you my final thoughts. So this data validation approach that I've presented provides us with a set of tests that can be shared publicly, even when the data itself cannot. It really enhances the reproducibility of your work because it codifies otherwise unwritten information that only the person who made that data set would know. And so we can really use these tests to reassure the people using our data that it satisfies specific expectations, and it might even inspire them to make their own. And on a final note, I just want to say that I think data sets are only getting larger. And I think that understanding the methods that underpin the creation of those data sets is increasingly important. And so creating this set of tests that your data must pass and sharing those and the logic behind them is really important for reproducibility. Thank you.
Thank you very much, Lindsay, for the very interesting talk. I know if I ever have any questions about the historical debates in the Australian Parliament, I know who to ask. So if there are any questions from the audience in person, please raise your hand, and on Zoom, just please electronically raise your hand. Maybe I'll indulge myself and ask a question. So you use the example of time expired as going through and validating your methods. So obviously that was just one example. when you found these data issues, was there some kind of threshold that you developed in order to determine, in order to